Alrighty?
Okay, yeah. I think I'm gonna give you another molecule if you
Sure,
don't mind.
absolutely. I think we can put it on this page too.
Thinking of one. Do you know what creatine looks like?
Um, there's I believe
That
there's
just came into my head because I saw it in my room.
a urea iguanodinal group in it, but that's all I can remember. I might even be wrong on that. I can
Would
get you
that
the
be a
creatine
good
quick.
sample? So like
Sure.
try on?
It might have a charge. Creatine. If it has a charge, that'll mess us up. No, it is iguanodinal. I'll just copy down what I found on the internet. H2N and H and methyl and an acetic acid on this end. Yeah, we can do all the peaks there. We'll call this one left to right. We'll go A is different than B, is different than the 3 H's on the methyl. C is different than the CH2. Now that's a special category there because it fits 2 entries on our table. It's different than E. And A would be H on a nitrogen, as is B. So what I'm going to do is look for the ranges for those two. And I'm going to make this higher in the range because it's an sp2 carbon, which will have a little bit of an inductive effect compared to an sp3. Okay. So, but I'm going to put them both in the same range, A and B. And the table says H attached to nitrogen. I lost it. Where did I put it? Where are you? Oh, yeah, it's PDF. Wrong PDF. How come it's not open in a different window here? Didn't we have that exam open?
I don't think we ever opened it.
We were looking at the table, though.
I never saw it at least.
You never saw the table?
Oh,
Yeah, we had the table.
yeah, I did see it for
Don't
a
tell
split
me I
second.
closed the table. Don't tell me. Table's gone. All right, bear with me here. We got this. We got snipping tool. Don't need that. Portal, HSC. I closed Moodle entirely. Coming right up. 242. A lot of classes. And just any of these test ones, fall 16, sure. And should be popping up here any second. There we go. Okay, so H on N. I see it right here, don't you?
Yeah.
H on N. I'll pick one to be closer to 4 and one closer to 2. And there we go. That's one of those ones you were talking about with a wide range. So A, B, C, D, E. Closer to 4 for B. Closer to 2 for A. We'll just do where's the peak for now. Now here we have an H for C here. We have an H on a C on a nitrogen. Let's look for our closest match on the table there. And H on a C on a nitrogen. H on a C on a nitrogen. H on a C on a nitrogen. See that?
Yeah.
Right there? So 3.5 is a nice number, isn't it?
Yeah. 3.5
3.5 for C. And on D, I see it's a combination of the same as C, H on a C on a nitrogen. So that was 3. So D star is a 2 category item. The 3.4 to 3.6 was 1 category, and it's also what we call alpha to the carbonyl. Stay tuned for the discussion of that in chapter 16. But when you're on a carbon 1 away from a carbonyl, you're called an alpha carbon, and H's on you are called alpha H's. So let's look for alpha H's to a carbonyl, and they are down here. I would say the CH2 one's a little closer, although the range is almost the same, isn't it? So 2.2 to 2.6 H attached to a C that's alpha to a carbonyl. So 2.2 to 2.6 fits that category as well. Normal RCH2R, that's if there's nothing special going on. Normal, that's like a baseline we're talking about here. RCH2R is closer to 1.2 to 1.4. So let's give numbers for each of these categories. Just smack that in the middle. 3.5. Wow, what did I do? I don't even know what I did. 3.5, 2.4, 1.3. And the question is now, how high did you go up when you put it in this category? And the answer is 1.1. How high did it go up when you put it in this category? And the answer is 2.2, correct? Just did a subtraction. Yep. So if you start at 1.3 and the combined effect is 3.3, right? 2.1 plus 1.1. So 3.3. And your number that you would predict for that peak is 4.6, correct?
So
it's an additive effect of being in two categories is all I'm trying to say.
Right, like they're going to affect each other. Why'd you use RCH2R for
well,
D?
I had to. What would be the closest match if this isn't special and this isn't special?
Right.
Just call them R.
Because there's no NCH2R.
I wouldn't say it's closer to RCH3, would you?
No.
That's another category that you could use for your baseline, but it's not as good a match as this baseline, right? And that I call a baseline. So find the closest RCR thing to start with as your baseline, and then what's the effect of being in each category. And then E is a carboxylic acid, which is our highest entry on the table. I'm going to put it at 11. Sound
because
good?
Of all the
1.5.
de-shielding.
Oh, because it's a proton.
Because you have two very.
No, think about it. What does the word proton mean? H with what charge?
H plus. It's a hydrogen ion.
Why does it have a plus charge? There's no electrons. What causes shielding? Electrons. You've removed the shielding of in a carboxylic acid. You've removed the shielding almost entirely.
Yeah, because you have two of the very electronegative oxygens.
Yeah, it's basically this thing spends quite a bit of time not even attached to the oxygen, but as a proton.
I read about one thing. Do we have to worry about what's it called? It's called like exchange. It's like when there's like a small amount of like base and like whatever solution it can just pull
Yes, there's a section in the book you should read called hydrogen deuterium exchange.
Right. Yeah, I read like some scientists doing NMR will drop like some deuterium water.
Right. And they see if it ends up incorporated in a certain part of the molecule. And that's how we learn about mechanisms. You say, oh, the reaction happened there when I added some deuterium in my water and it ended up incorporated in my molecule. Therefore, there was a reaction happening at that position. So let's finish this molecule. A, we don't do neighbors on anything except for H's on carbon. I don't know if I mentioned that before. So I don't want to talk about neighbors for H on N or H on O. Everything for H attached to N or H attached to O, that's these two and this third one, are singlets.
So A doesn't have any neighbors.
And B doesn't have any neighbors, and E doesn't have any neighbors because oxygen and nitrogen prevent neighbors from talking to each other. And if you can't talk to your neighbor, why did I just put an E there, didn't I? And if you can't talk to your neighbor doesn't exist. It's like they're not there. Okay, now C is, there's not even a carbon here, so there's no neighbors. It's got to be H's living on a vicinal carbon are called neighbors. If you don't have a vicinal carbon, you don't have neighbors. This molecule is full of singlets everywhere, isn't it?
Yeah, a
D,
lot of nitrogens and
you
oxygens.
can't count a nitrogen as a neighbor, so don't even look to the nitrogen. Are there any H's on this carbon?
No.
No, so you don't have any neighbors there either. H can't talk to this molecule is just a bunch of singlets. It'd be a very boring spectrum, wouldn't it?
Yeah.
But the position of the peaks tells us information, and how big the peaks are tells us information too. A would have a height of 2. Why? Because there's 2 hydrogens called A. B would have a height of 1. Why? Because there's 1 hydrogen called B. C would have a height of 3 because there's 3 H's contributing in C. And D would have a height of 2 because there's 2 hydrogens called D. And E would be a tiny peak of 1 because there's only 1 peak called E. 1 hydrogen, sorry, called E.
Can you explain? Oh, wait. So A has a height of 2 just because there's 2 protons attached
Yeah,
to
there
that
are 2
nitrogen?
hydrogens living here. Each one contributes to the height of the peak. If you have 2 of them, that's twice as high as a peak that has only 1. And you know, when I said twice as high, I meant has twice as much integration under the peak. But it gets tiresome saying that, so I just say twice as big.
And then C, we use all 3
C would be
hydrogens
a
and the
height of
methyls.
3 compared to this, which is a height of 2 compared to this, which is a height of 1. There's all 3 H's on this carbon. 1, 2.
So heights have nothing to do with neighbors.
No, that's a totally
Okay.
different story. Yes. The easiest question to answer is this third question. You should always do that first. Just count up the H's. And you just write it down. All righty.
All right. Okay. Okay, this is making more sense as I'm actually like trying to get some of this done and doing some of it.
I think this would be helpful to other students too.
Can we do another, but this time you can put down a molecule unless Mo has something he wants to